Hi friends, welcome to the series of lectures on electromagnetic fields. In this lecture, I am going to explain you about calculation of inductance of a toroidal coil. These toroidal coils will have different cross sections. In this class or in this video, I am going to explain you a toroidal coil that has a circular cross section. So, this is the toroidal coil. The toroidal coil, understanding the concept of toroidal coil is nothing but is very simple. So you have seen circular cross section toroid coil will looks like a tube. So you might think that it has a crude example, but the best example to understand the shape of a toroid. Okay, have you seen any tube, a tube that we use to fill air in the wheels of a two-wheeler, like your bike or scooter, anything. So when your bike or scooter got punctured, the mechanic will pull out, take out the tube and he repairs it. Once he repaired it, he fills that tube with air. So the shape that was formed is a toroid. So that you imagine that over the outer periphery of that tube you wound a conductor. So if a conductor can be wound over such kind of geometric configurations, we call it as a toroid. So that this toroid will have a radius A, where A is the radius of the toroid and rho naught is the parameter that varies from the center. So if you look at, this is the inner radius and this is the outer radius. Okay, so here consider the radius of the toroid as A and the outer radius of the toroid as B, and the toroid is wound with n number of turns over it, so that the flux density inside the toroid is, because it is a circular one, the flux density inside the toroid is mu naught n I by 2 pi r into A pi. Now to find out the flux that is linking with the toroid, then pi is equal to integral, closed integral over the surface s b dot ds, but the value of this ds is equal to r into dr d theta into A pi. Now the total flux linkages is equal to integral, this r is varying from A to B and this pi varies from 0 to pi. Now we substitute the value of B, mu naught n I by 2 pi into r, A pi dot r t r d theta a pi. A pi a pi, the dot product of a pi dot a pi is equal to 1. Then this pi is equal to integral r is equal to a to b integral theta is equal to 0 to pi mu naught ni by 2 pi r will get cancelled here, dr d theta. Sorry, here r will remains left, r dr d theta. R dr d theta d pi. Okay, so bringing the terms or separating the terms, this pi is equal to mu naught ni by 2 pi integral r is equal to a to b dr integral theta is equal to 0 to pi d theta. Simplifying these integrals separately because they are independent integrals, we can write them as mu naught ni by 2 pi b minus a into pi. So pi will get cancelled, is equal to mu naught ni into b minus a by 2. Okay, so this is what the value of flux linkage is. Now, the self-inductance of the coil, L is equal to total flux linkages. We know that pi is the flux that was produced by the current I, and N is the number of turns, so that the number of total flux linkages is equal to N into pi divided by current to which they are linking. So N by I into value of pi mu naught ni b minus a by 2. I will get cancelled. So this value is equal to mu naught n square b minus a by 2 is the value of inductance of a toroid coil having circular cross section. As you know that the units of inductance is Henry. So the inductance of a toroidal coil is equal to L is equal to mu naught n square into its radius b minus a divided by 2. Okay, so this is how you can find out or you can evaluate inductance of a toroidal coil. Thank you for watching my channel, my lecture. Keep watching my videos for more interesting concepts in electromagnetic fields. Until then, bye.